Okay, hello everyone, and today is Finnish Independence Day, and as usual around this time, I make some kind of coding project where I do something related to that, and also to the Romanian National Day because I'm originally from Romania, and that one was just 6 days ago. It's on the 1st of December. 1st of December. Yeah, and the idea for this year is that in Finland there are these candles, like blue and white candles that people usually light up on Independence Day. They look like that. And I thought that I'm going to make something similar, but it's going to be a small kind of fire simulation and with the candle at the bottom. And it's going to appear on your phone so that when you tilt your phone like that, it's going to still flame perfectly straight, hopefully. I don't know if it's going to work or not. I haven't tried coding this before. It's an idea that came relatively recently. I did do some kind of candle like this a few years ago, but it didn't have this kind of tilting possibility. And also, yeah, I'm not sure how to incorporate Romania into this yet. Maybe I can change colors based on something. Let's see how this goes. So, yeah, starting with this empty HTML page here and empty Visual Studio Code. So let's start writing this basic HTML. And in the head, I'm going to type the title of the document. Let's say interactive candle. Oh, hello everyone, and hi Frank. Yeah, now I'm getting a little bit of pressure here. Oh no, I have to code something good. So, it's going to be a Canvas app. Let's try to see if what we are doing here is working, if it's having any effect. So refreshing the page and going into the elements, I do see the canvas here, but it's not really visible. It's transparent and here in a corner there. I want to have it span the full screen size here. I think that's a good idea. So let's do that. And I'm just going to give this an ID. And maybe in JavaScript. So script here, like so. Depending on how big the project is, I'm going to start including JavaScript files there. But I'm just going to start with the basic setup here and see how many of those files I really need. No, I haven't heard. What is this HTML lang? And hello, hi Elvis. And yes, this is live. Let's put this like so. And maybe give it a background color so that we know it's affecting. Style. Okay, so seems like it works. And there is this small padding that the browser gives us here to the body element. We can remove that. It's a margin actually. Margin. If we set it to 0, then that disappears. And to make these scroll bars appear, we can set overflow to hidden. Yeah, I'm talking in a little bit funny way today, because I recorded 3 videos of phase 3 of the self-driving car course just before this. So I had a lot of talking to do there. And yeah, my throat is kind of sore. But I hope you can understand properly and that this is going to be understandable. All right. Now, these styles, I was supposed to add them to the body. And now it's fine. Okay, so having the canvas now filling the screen, we could somehow test how this looks on mobile devices as well. Like if I'm going to start this mobile, select a mobile device here, it doesn't really do anything else than set the sizes. Like it's not really an emulator or a simulator. It's just selecting a kind of screen size to see how this application looks like. And I'll eventually have to test on my phone to see how the thing really looks in practice. But just because I do want to have an idea of how this application will look like on a phone, I'm going to choose one of these from here, from these developer tools. So now I can see the application, how it would appear to be on an iPhone. Okay. Now I want to draw this candle, and maybe I want to draw it at the base and give it a height. So height would be the parameter. Maybe that is all I need, really. Let's see. Aha, ystävät. That means friends in Finnish. Okay, so let's pretend that we have this code already, and we say here, let's make it an object. Let's work with objects. So I'm going to include here candle.js. Maybe I want to have multiple candles, and that's why I'm thinking about using objects this time. And if I control click on this, it's going to create for me this new file. But assuming the candle is already there, I can say candle is a new candle, and let's say the XY location where I want this to be is going to be center of the screen on X. So this will wrap in an object here. So I'm defining the object basically here in the parameter. X is going to be half the canvas width, and Y, let's have it in the middle for now and then think how it looks better. So height divided by 2, and the height of this candle, maybe it should be 30% of the height of the screen, something like that. And this candle, we now go here and define it as a class. And the constructor has these options there. Like, this is an object now in the way I'm defining it, so I could take out from there options.x, .y, and so on, or I could even destructure it here and say that it contains the x, the y, and the height. So this is better because I don't have to type options dot all the time. But I could store these properties so that the candle knows where it is in the class attributes. So this dot x like so. And this should work. Like now if we go here and refresh this page and go into the console, of course there's no candle there. We need to implement a way to draw it, but there is here. There is a candle defined in the global scope. So it's a global variable at the moment, and these are the properties, the x, the y, and the height. So let's give it a way to draw itself. And it should have a parameter what is going to use for the drawing. So typically the canvas context goes there as the parameter, and we are going to tell this candle to draw on the context of the canvas. So let's have a reference to that. And pass it here to the draw method. And nothing is happening because the method is empty, but let's make it draw something at this x and y location. Maybe just a simple circle. Begin path. Arc at this x, this y, with the given radius maybe 10. And a full circle, so from 0 to math pi times 2 radians, and let's fill it. So this is the dot in the center screen. Let's make also the dot with the height offset. So it's going to be at this dot y minus the height. So this is how the candle would appear here. And really, I would like this to be lower and bigger. So I want it to kind of fill the whole screen. So when defining the candle, I'm going to set here that the y value, it's not going to be half the height. It's going to be maybe half times 0.8, so 80% from the top. And the height can be bigger, maybe 60%. This is good, but I want a smaller height, maybe until somewhere there. Yeah, because I want here to be space for the flame. Oh, yes, very good observation, Daniel. So I didn't read that, but you basically told me exactly the value of what I'm going to use for the canvas height. Sometimes I think you guys are reading my mind. Okay, now how do we draw this candle? It's basically it's a thin rectangle. That's it. It does have a little bit of curvature, but I don't know if we really need to bother with that. I mean, when you see them from far away like this, it almost looks like a rectangle. Let's begin with that. So maybe we style it better afterwards. So now we have this point and this point. This is essentially the bottom point. So I'm going to have a variable here that helps me know what this is. Otherwise, this code is very hard to understand. So bottom is going to be a point with this x and this y, like that. And top, this is the top point. It's more complicated than bottom. Right. And now what I'm drawing here are bottom x, bottom y, and top x, top y, essentially. So it's easier. It's easier to read and easier to know what these are. And if I look at this code after a week from now, I'm gonna know what it is because it's telling me this is bottom, this is top, and here drawing 2 points. Of course, this is somehow cryptic. What is this pi and whatever? But I've seen this so many times that it's clear. But this was something a little bit, you have to think about it all the time when you see it. So having variable names that mean something are useful. And at the moment it does the same thing. So let's have a width for this candle also. And I'm actually not going to say it's a parameter because I think they are somewhat standard. So I'm just going to use a fraction of the height. Maybe, probably even less than that, but let's just see how this looks like. So really what this point is, it's bottom center, and this is top center. If I want bottom left, then that's going to be bottom center minus half the width. And same goes for top left, but relative to top center. Okay. And now instead of drawing circles here, I can draw a rectangle. From top left, actually I don't need bottom left. Maybe I will need it later, so I just comment it out. Top left x, top left y, and then the width and the height. And it doesn't work. Oh, not a number and undefined for some reason. Okay, this top left, I defined the x value here, but not the y. Like so. Let's remove this bottom left because it's not proper anyway. And now still some problem with the x here. Top center dot x here. Syntax issues. So this is now, okay. Nice. Oh, really? Hello, Bruce. So I'm not seeing you, but it's first time I'm reading your comment live. And hello, Mostafa. Okay, so this works. And It's thinner. Let's make it thinner. So let's have this percentage be... I wonder if it's too thin like this. Maybe too much. Let's say... I think this is about right. Okay. Now I want to get the mood right, so let's change this background color of the canvas to, let's use a dark gray, maybe something like this. Okay, and the candle, it's mostly white and blue at the bottom. Let's start with the white. Okay, and the blue at the bottom. We have to decide where the center point is. Like, where does it become blue? And I think I'm just going to use the middle. It kind of looks like that. I don't want to overcomplicate parameters here. Yeah, so middle left is going to be top left. No, yeah, top left X, and something like that, I guess. I would like to align these better like that, but I think my automatic formatting system might not like it. So maybe I stop using it now, but I find it easier to read like this. So this middle left is where we start to do another rectangle, a blue one, and the height is going to be half the height. Like that, pretty much. So I'm just drawing another rectangle on top of the first one. I would like to see some curves here, but I don't want to risk not getting this project done. So I'm not going to spend effort into that part, not just yet. And also I'm gonna keep it as simple as possible for now, so no particle physics here. Just some kind of shapes to see if the orientation change works on the phone or not. So, the tip of the candle, that's also something important. Where do we want that to happen? So it's from the top center. That's the bottom of it. And what should we draw there? I think I want to use an ellipse. So let's have some properties here also, like the flame height. Maybe also as a fraction. So let's try with that. The flame height. Okay. And this top center gives us the base of the flame. Let's get the center of the flame. So this is the X, and Y is going to be minus flame height divided by 2, like that. Okay. And here we can say begin path, fill style yellow, and ellipse. Now ellipse, this function has is similar to the arc. First is the X, so we have already flame center X, flame center Y, and now we have to give it a radius. We do have this flame height, and I should write these on separate lines so that I can explain what they are. So this is the X, obviously. This is the Y. This is one radius, and I have to specify another radius as well. Let's say this one is radius 2, and it's going to be half the flame height. It should be flame width there, but let's make flame width as well. And this is going to be relative to flame height. I think it's more natural like that than, let's say, just half of flame height. Okay, now the next parameter is the rotation, and I'm just going to put 0 here. And the last two are the same as the arc, so 0 and math pi times 2 for the full circle. There's actually one more parameter, but I almost never use it. It's if we want to draw this clockwise or counterclockwise. But it doesn't really matter when we draw full shapes here. And fill. Have to fill the ellipse. And it's not great. It's not what I imagined. The radius is supposed to be just half of these. This is one of the issues. Radius is going to be just half of whatever that is. And the other issue is I messed these up. So this here is actually the radius on X, and this is the radius on Y. So looks like that, but I want the flame to be bigger. So yeah, wrong direction, exactly. But also the fact that the size of the flame is double that of the radius that I specified there. So bigger, 2. I think this can still be half of the other one. It's maybe too much, but I think for debugging it's okay. I want to keep it like this for now. Now the orientation handling. I haven't done that in a long time, and I don't remember how it goes. But I do have many videos where I teach about it, like I think this one where we make the app to measure how tall trees are. We do some kind of triangulation there, and it also uses the orientation, and it wants to use the camera, but it's in use. So it's not gonna work. I don't care about it working. I just want to see how to handle the orientation, because it's probably faster than looking at the documentation. So an event listener to the window and then something here. I think this is more complicated than what we need. But I will start with this. So the event listener for device orientation, and then the callback function, this on orientation change. Let me just copy it from here. And event.beta, event.gamma. I think one of these angles is going to be important. Probably the beta, if I remember right. But let's log it. And now my laptop doesn't have that kind of orientation sensor like what you have in your phone that figures out in which way the screen should be showing. But it's okay, because these developer tools have more tools here and sensors. So you can actually simulate these somehow. Like custom orientation here. And now you can see some things appearing there, and it matches what you see here. So this screen lets you play with your phone, a virtual phone, so that I don't need to somehow work on my phone directly there. And I think the angle that I'm supposed to be looking at is actually this gamma. So see this -18? -18, that value for gamma gets lower and lower when I tilt the phone like this, and higher and higher when I tilt the phone like this. Also important to note that if the phone is somehow facing down like this, those values are flipped. It's complicated. I don't want to get in the details there, but I think these are Euler angles, and some unexpected behavior happens because of that. But people tend to hold their phone like that. So when you hold your phone, it's like that. It's not like that. Like you don't do that when holding the phone. So I'm just gonna assume people are holding it a little bit tilted upwards, like that. So the gamma is something that we want to look at, I think. So gamma. Yeah. So now this gamma here is logged in the code. Good. So we need to send this gamma to the candle when drawing it. So it needs to somehow get the angle and redraw the candle using that angle. So candle, draw with that angle. Like that. And let's just pass this value there and see if it works. I'm also going to need to clear the canvas, but just to see Okay, nothing works anymore because you have to move the device for it to trigger. It's inside of this on orientation change event. So only when the orientation changes, it's going to draw the candle. And I think it's drawing a bunch of candles over each other now, every time this is moving a little bit. But we don't really see that happening there. So drawing at an angle, I'm going to go here and tell this ellipse that the angle, like by default it could be 0, but this angle is the rotation that I'm going to give to this. Yeah. You can see some crazy things happening. So if I move just a little bit, the problem is these values here are in degrees, but this value here is expected to be in radians. So let's convert this to radians. I'm going to make a simple helper function here. Like so, and use it on the gamma to get the values. And something is okay, but without clearing the canvas, this is quite confusing. So let's do that as well. I'm going to go here, and every time I want to draw this, I say clear rect 0, 0. Maybe I will add some complex effects, but if I don't get the basic functionality down in time, I won't. So is this correct? I think this is exactly opposite direction what I want it to be. Somehow I have hard time telling. I think I really have to test on my device. So I think it's the opposite what we want. So I'm gonna have to put here minus this value. And now when the phone is tilted like that, the angle is pointing hopefully upwards. I have to adjust somehow the angle here. It's a little bit tricky maybe, but I just want this oval here, this ellipse, to point upwards on my phone. And maybe it's time to test on my phone as well, because this is just a little bit confusing. So I'm gonna take a while and put this code on my website, and I'm gonna give you the link as well so you can play with this if you want. Aha. I'm working on the self-driving car course, so that's why you get to see here a lot of crazy stuff. Mhm. Yeah, I have to figure out how to do that. But I don't want to bother with moving the center of the ellipse. And the reason is, if I'm gonna do something like have particle physics or whatever, I'm really gonna be only interested in what is the direction of gravity and also the place where the flame starts. So bothering to fix this issue now, it's not my prime concern. So this is the link. I'm pasting it in the chat at the moment, and I have to type it on my phone as well, and it's gonna take a while. I don't really like using phones. I'm very slow at typing on my phone. I'm kind of like Leonard from that when I teach about coding practices. Okay. This actually works. I'm gonna try to show you my phone screen. So but not perfect. See, it's not perfect. It is tilting a little bit and kind of vertical, but I think it goes a little bit over. Hard to explain. I know how to get it to be even better, but I think it's gonna be overkill, because now the main reason why this effect doesn't work well is that this center of the ellipse is making it bad. So I'm gonna stick with this approach, and then if time I might show you a better way to detecting what is really the up direction that the phone should have. It yeah, but anyway, I might have to leave that for some other time. Now, sure, let's make it look better. So instead of that ellipse, let's work with the visual effect itself. I'm gonna go back to my screen here, because this is really the best place for debugging. Not my phone. I don't like that small screen there, and I can't show you what is going on. And in the candle, it's going to need to somehow it will give a better effect. I was saying before why I don't want to do that and move the center of the ellipse, because if I do this particle physics now, I just want to know what the base of that ellipse is, and gravity will do the rest. So I don't use the ellipse anymore. But this flame height and flame width and the flame base is something that we're gonna need when defining the flame. Yeah, let's make an object called flame. So I'm going to copy this and call it flame. Like that. And the candle is going to have flame, new flame width, this flame height, flame width. I don't know if this is going to necessarily be a useful parameter, because the particles will determine how big the flame is going to be. So there might be other parameters for controlling that. Let's just have these here in case we need them later. But I want to know where the flame should start. So that's this top center from here. And then something like flame size or whatever might be secondary parameters, or just keep there some part of the flame itself. Let's see. Okay, and here instead of ellipses, just remove this and tell our flame draw update. I'm not sure what to call it, because it needs to update the particles that are there. I could have two things like this. Or just update on the context. Maybe this is enough to be clear what is going on. Okay, so it also needs to know what is this angle. So let's pass here and start defining the flame. So flame and this was the base location. And update on a context and angle here. Let's just draw the circle here to begin with, make sure that what is happening now works. So yeah, I want a dynamic fire. I want one that moves. And new particles are coming all the time. Okay, so this small point here is what I'm getting now, the base of the flame. Maybe red is a better color. And let me call here this on orientation change with gamma of 0 when the page loads, because then this works and without needing to move this thing every time. And now let's try to do the particle physics here. So particles, an empty array, and they will update here, and then we will have to draw all of them somehow. And maybe we'll use this code for drawing the particles, but we have to loop. So we do that. And that. Okay. And here we have to update the particles. So and here we need to pass that angle, like in which direction do we want the particles to be affected. How's it going? I'm a little bit tired because I recorded 3 videos from the self-driving car course phase 3 that is coming up in probably end of January, beginning of February. And at the moment we have a candle that somehow is affected by the phone orientation, But now I cancelled visualizing that part, and I'm working on a particle effect for the flame starting in this spot there. So let's see. Particle update. Okay, so I'm thinking about making these as objects as well. I don't want to make a new file there, so let's just have here the particles associated with this flame object, and we have to define these particles also somewhere here at the top. It's going to be defined at an x and y, so something like that. And an update method for it. And this is going to be an angle here that tells it how to move. So we have to move these according to an angle and some kind of speed. We could also use a velocity vector here that combines the speed and the direction, but let's just try some things here. Based on the unit circle, so this dot x, we increase it by the cosine of this angle times some speed. I don't know if I want this to be a global variable. Maybe something like that. And see what we get. And let's copy this for y, but with the sign here. I do have videos about those kind of trigonometry things here. If you need to understand these, but I don't feel like going into the topic now, and those videos were much better designed for teaching these than I could do in the live stream. So it's not that important, I think, to focus on it here. Yeah, and the base disappeared because in the drawing we're just drawing the particles, and the particles are empty. So we need to generate them somehow. Many of them at this x and y location. So how many do we want? That's maybe a parameter that can be here. How many particles should the flame have? Maybe 10 as a start. And then this one, something like that. And what? I know what's going on, but this is funny. This could be a kind of a game. Control the particle with your phone. So these gamma values are apparently between minus 90 and 90. So that basically means the particle is only going to move to the right in this case. Yeah. because we're basing this on the unit circle. And I would need to offset them by 90 degrees. So here the angle, it needs to be offset minus 90 degrees, but now we're working in radians, so yeah. And now moving the phone, this particle wants to go up. You may also be wondering, where are the 10? Yeah, it's like a game. Control the flame particles. You may also wonder, where are the 10 particles? And they are just overlapping each other because we update them in exactly the same way. So we would need to add here some randomness to the angle. For them to differ. And I want a value that is negative and positive. So now it's going to be between minus 0.5 and 5 at random. I mean between minus 0.5 and plus 0.5. So this one is going to make these particles spread out a little bit more like that. It's funny what I'm seeing here. And this only updates when I'm moving the phone, so it's kind of stupid at the moment. But it's going to be better when we have particles spawning more and more, and they need to disappear at some point and probably regenerate. We'll use an object pool for that. Okay, so this is interesting. I think we can work with this. Let's have more particles, maybe 50 of them. Can't really tell any difference because they don't change enough here. Yeah, let's give these particles a lifespan. So maybe the lifespan will be variable. So this life is going to be a value between 10 and 20 at random. So a random value between 10 and 20. Oh, smoke. That's a good idea. Let's see if we get to that. And this life is just the number of frames. So this life will decrease basically at each frame. And we have to regenerate the particle if its life is less than 0. So if particle life is less than 0, I don't want to remove it from the array. I just want to reset it at x and y. So particle reset could be a useful method. So reset So I have now a copy of the start, and when we reset, we put it back to where it was in the beginning. Aha, and resetting also has to reset its life. So I don't like that this code will be copied twice. Because if I don't like the way the life works here, I'm gonna have to change it here, and it's not great. So what we're gonna do is I'm just gonna define this start here, and then remove this code and do this reset. It's gonna set these values and update the life, and I don't have redundant code there. Okay. This is much better than I expected it's gonna be with this in this debugging, really. I expected it to be much more worse than this. I'm surprised. I'm happy with this result. But the flame is not moving all the time, so let's fix that. We need to do an animation loop here, not rely on this event listener to update the candle. But this angle should be a global variable, because in that way we have access to it in the animation loop as well. So here we don't define a new angle, we just set it to the value. This drawing stuff is gonna happen in a new function. So that's what we do here. And then do the animation loop. So this is gonna call animate again and again, many times. This is not needed anymore. The default value of the angle is 0. So the flame is going to the right like that. But if you move this, then the angle is going to update to something better. Okay, it shouldn't be 0. It should be minus 90 degrees in the beginning, like that. And now I think I can update the code on my website and see how this looks like on the phone as well. So it's the same link from above, but you might need to clear cache or something if you test it. Because the phone remembers the previous code, most likely. And I'm gonna just open this in an incognito window here. Okay, it's not bad. So that's the, okay, that's the phone. Okay, I'm confident that this is going to look quite nice by the end. So seems to be all right and affected by this angle like that. It's not perfectly pointing up all the time. Sometimes the angle is a little bit messed up, and I don't really know if I have the mental capacity to fix it right now. But it's good. I like it. We have to make this flame bigger. So I'm gonna work on the visuals next. I'm gonna make this flame bigger, and that's really just going to have a longer lifespan for the particles. So somehow the particle lifespan is going to affect the size of the candle. Maybe let's just see how it looks like. So doubling these values. Yeah, okay. The flame should have that kind of distinctive shape. Somebody was mentioning before that, that circle at the top and two arches connected, something like that. But I would like the particles to have something gluing them back together, if that makes any sense. Like spreading out bad and then somehow going towards the same point somewhere here in the distance. I might be overcomplicating myself very much, but I would like some kind of attractor there at the top and the points spreading kind of randomly here at the bottom and then navigating towards that point. Let's see. Let's call that point let's have a flame size also. And this attractor, we don't need it here. It updates. So this size needs to be stored. And let's draw this differently. So at the end here, I'm going to say, I'm gonna just copy this green lime and that. So this attractor here, I want it bigger actually, because this size flame is, well, it's too big. Candles don't have such big flame, but I want it to be bigger than where this attractor is pointing to. But you see, it's respecting the angle as it's rotating there. So let's have its size be a little bit bigger, like that. And now figure out what we do with these particles to get there. How do they get to that point? Start off somehow crazy and then get to that point. So the angle of the particle, I want it to be crazy. I want it to be bigger, maybe like that. So the start angle should be crazy like that. But then the update shouldn't depend just on this angle. But also on this attractor somehow. So this x and y is where the particle would move if only affected by this angle, but we also want to move it closer and closer to the attractor, really. And how close to the attractor should depend on the lifespan. Like if the life is getting closer to 0, at the end I want it to be at this point. So I want to somehow move the particle closer and closer to that as this life is approaching 0. Something like that. And I need a way to do this interpolation here. So it's just basic linear interpolation. So I have a video on that as well, and it's really well explained. So I don't go into this detail now. But it's a simple function. So when t is 0, then this is 0, so it's at a. If t is 0.3, for example, then this difference is scaled by 30% and added to a. And when t is maximum 1, then this difference is maximum. And you can also kind of tell that a and a cancel out, so you get b. You get the value between a and b depending on this t value. So now here I want to get a value between the attractor and this one, and to get closer and closer to the attractor. Yeah, so life starts up at max life. That means that this is going to be 1, and then it decreases slower, more and more towards 0. So that means we're getting closer and closer to the attractor if this works. Let's refresh. Okay. Kind of what we want. Whew. But I want this influence to get... I want them to somehow spread more in the beginning. So I only want this fraction here to get closer to 0 later on. Let's have a t value for this. And play with it a little bit. Usually I try things like raise it to the second power, for example, or fourth power, or a fraction. Yeah, I think this is good, but maybe when the randomness happens here, we should use a smaller value. Or not. So this is between -half and half. Times 2 gives us between -1 and 1. And if we multiply by pi as well, it should give us the full circle. Some real craziness going on. Maybe we just want half pi here. I think this is decent. Let's see. Let's work with this for now. And here, maybe even a smaller value, like 0.05. And let's have the speed of these particles smaller. And the duration of the life longer. Okay. I'm just playing with these so that I get something that looks good to me. Let's try some extreme values here, like 70, and a slow speed, like 2. Just to see if we get some clearer shape of what is going on here. Okay, I realize what a problem is. When the particle starts or resets, we should give it this angle. This angle. And when generating the particle, we should also give it an angle like this. I want so that when a particle is created or reset to keep going on that angle. Like if a particle is fired in some direction and then I'm moving the candle, it shouldn't update based on the new direction. Somehow keeping a memory of the angles is what I'm thinking about. Sorry if I didn't talk enough recently, but yeah. And then here when we update, we actually don't use this angle. We use this angle. Okay, so now you can maybe see better what I was going for, but because of the random angles generating on each reset, yeah, because of that problem, I couldn't visualize exactly what I was looking for. And now this value here, let's try again with 0.5. So this would be the square root. Looks something like that. Let's try times 2. Yeah, it's way too much. So something like this is fine for me. What do you guys think? And okay, thank you, Spencer. I hope that what you learned is useful. And you're welcome. I'm happy you like the content. From front dive. Okay, now we can increase the speed again. So this would be a 10 here and 20 maybe. Wow, this looks much better than what I thought, really. Wow, it's crazy. Okay, yeah, flip it over and it's a rocket. I don't like that they are piling up at the end, so somehow maybe decreasing the speed, maybe having these speeds as attributes. Oh, still using this one. Yeah, this looks nicer, I think. Let's try a different proportion here. Okay, I'm kind of happy with this. So I really don't know how to explain these things on the fly like that. But I hope you understand some things about that it's using math to do it. I don't know. 3JS. Yeah, you could use 3JS for this particle effect if you want a 3D look. But you might have some troubles with the angles on your phone if you want it to flip in all the directions. I'm not sure. But anyway, so this looks good to me. And I don't need to draw anymore that attractor. I think that it's doing its job. The particles could have different colors. I don't know if the particle should remember its color, or maybe it should be based on its life. Yeah, that might be interesting. Let's try. Something like this, and the hue is gonna be, let's try setting a hue of 60 in the beginning. And this fill style, we set it to the color. So what we get now is this blue color, which is kind of nice. Yeah, you could make it pick from different colors, but I am thinking about making it based on this. Oh. Based on this hue from here. So a hue between 0 and 60 degrees maybe. But I can't remember if this is in degrees. Let's try again. 60. 60 should be yellow. Yeah, I think I had some messed up code before. So a value between 0 and 60, and it should depend on the particle's life. So something like that, and then let's just put T there and max life life divided by max life. So now the color is somehow changing like this. It's starting off as yellow and then going towards that. And you can play again with the math here, and the thing that I like to play with most is this, raising this to different powers. And now it's going to get more emphasis on the red. If you put here even higher power, even more emphasis on the red. And I kind of like this one. Let's see how it looks with more particles, maybe 150 particles. All right. And one thing we could also try is different global composite operations. So this is where we're drawing just the particles. And let's just save the state. I don't know why I pasted the XOR there. It's kind of obvious it's going to do this crazy thing, but I kind of like it. So XOR does this. I was thinking about maybe lighter. Or lighten. These help blend the colors a little bit better. Let's try giving the particles also some transparency. How about we give the transparency based on its life again? Doesn't seem to work. Yeah, okay. Let's see if my phone can handle what we did here. So I'm gonna take this code again and put it on the website. And then. Ah, it's pretty nice actually. So it looks like this. I don't like that it's not really moving exactly like what it's supposed to do. Maybe I tried to figure out the math for that one. But if you look closely, the flame really is moving somehow depending on the movement. Like some particles are being left behind when this happens. So let's see if I try to figure out the math or if I shape this candle a little better. I think I'm kind of running out of time. Yeah. Okay, so wait, there were some questions there. Okay. Phase 3 of the machine learning course, if it's gonna be not about generative AI. It's going to be teaching some other machine learning concepts. So it's not about artificial intelligence. It's maybe going to be related to this. Maybe gonna teach clustering, or maybe I'm gonna teach how to make an authentication system so that if you draw something, it recognizes that it's you. But I don't want to go into generative things because it's too hard for me to teach. I know it's hard to say it, but knowing how to do something and knowing how to teach something is really not the same thing. And I don't know how to teach it, at least not at the moment. So someday maybe. Yeah. Okay. Yeah, wobble like a flame. You can actually test this on your own device. The link is somewhere in the chat. Somewhere up in the chat. Yeah, but I wanted to have it accurate, and I know how to do it, but because I filmed so much other stuff today, I'm kind of tired, and I don't want to do that right now. But I still have some time, and maybe I focus on some other things. I forgot about Romania. So Romania's National Day was on the 1st of December. So this is what happens in Finland. In Romania, we don't have candles like this, but how about making this one be that as well? So Romanian flag is like that. And I'm going to try to define a candle like that as well. So maybe here what we will have at the top is color array, make it more general, right? And when we define a candle here, color array was white, blue. But I'm going to define another candle to the right. Candle 1, candle 2. And this one will be, let's end with blue, yellow, and blue. So that both of them end with blue. And this is going to be maybe 40% from the left, and this is going to be 60% from the left. Studying mathematics, I recommend practice. And also Manoj KM wants me to say his name or her name. Probably his name. Yeah. So now 2 candles there, and we want candle 1 and candle 2 to draw themselves. Now, they are at the moment just the same color scheme there, but that's what I want to change so that the other one has a different color there. So this color array is what I have to figure out. So here we should keep it, store it as an attribute, and we don't need these anymore. Yeah, it's a good experiment. I'm gonna give you the code at the end. You can actually take it from my website already now. So you can play with that. I don't know if I will have time. Flame center, we don't need it anymore. Bottom center, we didn't need it anymore. And here, when drawing this, so I had white and blue. Middle, this middle point, okay. I need to base it on this color array. So Let's draw it all with the first color array of 0. And then this is color of array of 1, if it's available, of course. So here you can kind of see what is going to happen with the second one. But let's assume that I don't need to check for the first one. It has to be at least one color there. And then loop here. Like so. Yeah. And after I'm looping here, this is what I need to make differently. So, and also this middle. Actually, I can use top left X here and the middle Y. So just the Y value. Let's just call it Y, is going to be like this. And like this. And why doesn't it work? Oh, here I have to use I instead. No, I minus 1. No. Why doesn't it work? I'm lazy to do the math. I'm really lazy to do the math at the moment. So I is going from 1. And for the second one, it's going all the way 1 and 2, basically. And here, dividing 1 by 3, dividing 2 by 3, this should be okay. 1/3 and 2/3. Oh, but not in that order. Ah. Oh no. I don't even know what I'm doing now, but I think this fixes it. It doesn't fix it. Horrible. Yeah, it should be a blue thing at the bottom, but I just can't concentrate anymore. I'm lazy. I just want to debug to see what happens. So I moved them at a little bit of an offset, and you can see the blue is there, but it's coming before the yellow now. Okay, I guess I figured it out. So okay, I think that Daniel has already some solution there, but it's just as I got it to work somehow. So thanks, but a little bit too late. And somebody said about particle sizes. I think you can play with that, definitely. I don't like how these look like. Like, somehow the colors are too many. It would be okay if the flame... Maybe it looks okay if this color is... Like, this looks okay-ish, but when they are mixed, somehow it doesn't look that great. We could use geolocation as well. And if you are in Finland or closer to Finland, show this one. If you're in Romania or closer to Romania, show that one. But let's try. I do have some tutorial about GPS and some distance measurements, but I don't remember how the code is in that one. It might be really made for teaching and not so much about I don't know. Okay, there seems to be a function here for initialize geolocation. I think this is making it call quite frequently. We wouldn't need it to be that frequent, but it's okay. And then on location update, it's this callback function here. So maybe this. We are not calling it anywhere, so it should be here. It asks me if I want to allow the location now, and I said yes, and I'm getting here these coordinates appearing there. And this sensors here can also override the location, like Berlin, and now we're in Berlin. London, and now we're in London, and so on. So, Maybe the color array shouldn't be part of the constructor here or the attributes, but when drawing it, color array. When drawing it, I'm going to pass it here, and this color array will not have this anymore. So I remove this from here. And now when drawing the candles here, we have to pass some color array. So let's say other way around. So two different color arrays here, and they are not passed like that. And let's let colors is equal to ROM colors, and this is what we are going to pass here, like so. And now refreshing this, you can see this ROM colors there, but if I'm going to say colors, thin colors, they change dynamically on the fly. So now I wanted to change based on our location and the distance to those countries. And I think that there is some distance calculation in this code. Get distance. I guess there are many things here for calculating the distance. So degree to radians we already have, and if I'm lucky, copying these will just magically work. Whenever that happens, I don't really know. But they should have latitude and longitude, and these have latitude and longitude. So maybe this will work. Let's see. So get distance. Here, every time we select the colors inside of the animation loop, if get distance, I also need to know where Finland is. Oh boy. I'm just gonna guess these coordinates, so I don't need to be perfect with these. Okay, so if fin location current location is less than get distance current location, colors fin colors, else colors ROM colors. Okay. Current location needs to be a global variable. And let's set it to Finland since it's Independence Day. Oh, okay. So it starts off like this, but if we switch to what is closer to Romania? Berlin? Maybe Berlin it is closer to Romania than to Finland. And then if we move to London, it's actually closer to Finland. So yeah, I did much more than I thought I will do today. And Moscow, Finland. San Francisco, Finland. Interesting. I hope these calculations are correct, but I think they should be. Sometimes distances are confusing when you see them on the map. You need a globe for them to make better sense. But I think the calculations are good. So, in the exact middle, show both. Yeah, if this would have a way to select locations nicer, I don't know if it, I don't think it has. But I would do something like that, maybe with some threshold. But yeah, so hope you like this, and yeah. Well, I think the coordinates are relatively valid. I mean, I think that you will find they are in those countries if I didn't make some horrible mistake. But I don't know which city exactly. I kind of like these candles to have that candle shape, like be a little bit curved there. Let's try doing that also and call it a day. So here in the candle, after these rectangles, I'm just going to try to draw some shape here. Let's make it purple. Move to, and now I want to move to bottom left. Bottom left, it's gonna be this x and minus this width divided by 2 and this y here. So from bottom left, I want to line to top center and line to bottom right. Let's have a triangle like this first. Top center is there, bottom right is not there. And middle left is not used anymore, so let's clean up. And bottom right, we just add here that and restart. That's the triangle, but I don't want it to be a triangle. I want it to be curved somehow. So let's try a quadratic curve with this as the control point. So I wanted the control point to be top left x, top left y. So not a line 2. And then the same thing with the top right control point. Do I want this? To bottom right. top right is missing now. Okay, let's see what happens now. Okay, this is kind of the shape that I'm looking for. That shape. Maybe this curve could be even stronger, but I'm happy with this. So what I'm gonna do is instead of fill, I'm gonna clip to this region, and I'm going to go before these other things, then draw those rectangles. Before clipping, I'm also going to save, because drawing the flame shouldn't be clipped to that region, and it should be restored here. So restore. Right, I think this is it. So candles changing their style. Maybe a better curve would be this Bezier curve too. Let's try it on one side. So, and I'm just gonna use the same control point twice. I think it's gonna make it go more this way here. Yeah, I think this is much better. So that's it. I think this is as good as I'm able to get it in this short time. Right. What do you guys think? Was this useful or just fun? At least I had fun doing it. I thought it's gonna be horrible because I was kind of tired going into this. Oh, okay. Yeah, you're welcome, Sajid. I'm happy that you find some useful things there. So, I'm done with this. There will be another live stream this year, and it's gonna be in 2 weeks, and that will be with Q&A for the self-driving cars. Let's try also, oops. Let's try also the app on my phone to see how, if it detects the Finnish candle. Hi, I'm just ending. Uh-huh. Oh, I didn't update the website. I was wondering, why doesn't this work? So the version on the website is here. Sending the link one more time, but this is I have to clear the cache. Oh, I didn't know it looks like that without this phone view. It's funny, I guess. Okay. So maybe use the phone view when you're debugging this, or debug it on your phone, even better. And this is the link. And now I try it on my phone. And it does work. It shows both the candles here. The flame is moving in the direction of the kind of the direction pointing up, but not exactly. The math there still would need a little bit of work, and probably to use a different event listener. But maybe some other day I'll teach you that. But it's still pretty good, so kind of respecting what the phone is doing. And if I move now and I go towards Romania and get closer to Romania, then these candles are going to change to the ones that you see on my screen here. So it depends also on the location, on the geolocation of the device. So hope you liked it. That's it pretty much. After the self-driving car series, I'm going to rest. So after phase 3 of the self-driving car course, I need the rest, because this phase 3 was, and phase 2, both of them, I worked at the same time on them, and they took a lot of effort, and I'm gonna focus on easier projects for a while, and then maybe come back to phase 4 or to phase 3 of the machine learning course, let's see. But I will take a break, maybe even a year or so. So I will do simple projects for a while to recover. But phase 3 should be coming in February or so. Okay, yeah, so see you guys.